Financial markets are full of uncertainty, and pricing complex financial derivatives like options requires robust mathematical techniques. Monte Carlo methods have become a powerful tool in option pricing, allowing traders and analysts to estimate prices when analytical solutions are not available. Why use Monte Carlo for option pricing? Traditional option pricing models, such as the Black-Scholes formula, work well for simple cases, but struggle when dealing with path-dependent options, such as Asian options or barrier options, American-style options, which can be exercised at any time before expiration, complex underlying assets, including multiple factors and stochastic volatility. Monte Carlo methods provide a flexible, simulation-based approach to estimate option prices under realistic market conditions. How Monte Carlo simulates option prices. Monte Carlo simulation works by modeling the future price paths of an underlying asset using random sampling. Here's how the process unfolds. 1. Simulate multiple possible future price paths for the underlying asset using a stochastic process, often modeled as geometric Brownian motion. 2. Compute the option payoff for each simulated path at expiration. 3. Discount the average payoff back to the present using the risk-free interest rate. 4. Estimate the option price as the average discounted payoff over all simulated paths. By running thousands or even millions of simulations, Monte Carlo methods provide an accurate estimate of the expected value of an option. Steps in Monte Carlo option pricing. 1. Define the model. Choose a stochastic process for the underlying asset price, e.g., geometric Brownian motion. 2. Generate random price paths. Use pseudo-random number generators to simulate future asset prices based on volatility and drift. 3. Calculate payoffs. Determine the option's payoff for each simulated path. 4. Discount payoffs to present value. Apply a discount factor using the risk-free rate. 5. Average over all simulations. The final estimated option price is the average discounted payoff across all paths. Advantages of Monte Carlo in option pricing. Handles complex payoffs. Useful for exotic options, path-dependent options, and high-dimensional problems. Flexible. Works with various stochastic models, including jump diffusion and stochastic volatility models. Scalable. More simulations improve accuracy, and parallel computing can speed up execution. Challenges of Monte Carlo methods. Computationally expensive. Requires thousands of simulations for accurate results. Slow convergence. Compared to analytical methods, Monte Carlo can be slower, especially in high-dimensional cases. Variance issues. Requires techniques like variance reduction to improve efficiency. Variance reduction techniques in Monte Carlo option pricing. To improve accuracy and efficiency, several techniques help reduce variance. Antithetic variance. Use negatively correlated random variables to decrease variance. Control variance. Use a known related function to adjust estimates and reduce error. Importance. Sampling. Adjust sampling distribution to focus more on relevant scenarios. Applications of Monte Carlo in finance. Monte Carlo methods are widely used in financial engineering for option pricing, pricing European, American, and exotic options. Risk management, estimating value at risk, VAR, and conditional VAR. Portfolio optimization, simulating portfolio returns under different conditions. Conclusion. Monte Carlo methods provide a powerful and flexible approach to option pricing, especially for complex financial derivatives where analytical solutions are impractical. By simulating thousands of possible future price paths, Monte Carlo estimates option values with high accuracy. Despite computational challenges, Monte Carlo methods remain an essential tool in modern financial engineering, helping traders and analysts make better informed decisions in uncertain markets.